go. Here we go, 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 here we go.
And welcome back to another episode of Containers from the Couch. How's everybody doing? Good to see everybody here on the stream. Thank you very much for joining us this evening. We have a special returning guest this week. And Stephen, please tell everybody who you are, what you're doing at AWS, and what are we going to be doing here today?
Of course. Thank you, Meshai, everybody. Thanks for coming out and hanging out with us today. My name is Stephen Follis. I'm a container specialist here at AWS. I've spent the better part of almost 4 years working with container customers on their journeys with AWS across ECS, EKS, and my first love, AWS Fargate. Excited to be with y'all today, back returning on Containers from the Couch.
Awesome. And my name is Meshai Casing. I'm a developer advocate of the ECS service team. It's kind of late and dark outside as compared to the people on the other side of the planet. Welcome, Mario. How are you doing from Italy? Thank you very much for joining us. Say hello in the chat. We would like to hear. Tell us everybody where you're from. How's your day going? Love to have you interact with us. So, Stephen, what are we going to be talking about today?
Yeah, so we're going to be talking about a topic that has been near and dear to many customers' hearts over the past year. It's all around how can we optimize workloads that are running on Fargate, both from a performance perspective and from a cost perspective. I know that's been a very hot topic given the economy of the past year. So we'll talk about how, some tips, tricks, strategies, ways that we can drive down and really optimize both of those facets when we're running containerized workloads in a serverless way with Fargate.
And this topic, if I remember correctly, you did a talk on the same topic at reInvent, correct?
I did, yes. So yeah, re-delivered a couple times at reInvent, had great feedback. I tried to kind of cast a wide net, so some nice little reminders, then a little more intermediate advanced tips as well. So a bit of a smattering of pieces. Had great feedback at reInvent, and really excited to be kind of re-delivering and sharing a lot of this content a couple months later here today.
Awesome. And the reason we're actually doing this session is because the session you did was a chalk talk, and for everybody who has not been to reInvent or participated at the event or been there, chalk talks are not recorded. So the only thing we do share after the event is the slide deck, but the talk itself is delivered in front of the people inside the room, maybe multiple times, like you said, but it's not something which everybody can experience either by catching the recording after the show or attending with a larger audience. So that is why we decided to actually go through this topic, which is kind of based on the same session which you did at reInvent. So over to you.
Awesome. Well, thank you so much. And yeah, the Chalk Talks are great. If you do have a chance to make it out to reInvent, seek out the Chalk Talks. I've been guilty of kind of being very breakout oriented in the past. Chalk Talks, totally different vibe, totally different environment. A lot of fun to be able to engage and talk with the presenters and have a great conversation there. So today, to kind of jump in, I've kind of tried to take what I had drawn on a board and stick them in some very basic PowerPoint slides. We've just got a couple. But we'll kind of walk through some of these today so that I'm not trying to record myself drawing on a piece of paper or anything like that. So maybe to start off with, two of the things we hear a lot about Fargate is Fargate. Oh man, it's really slow. It's not very performance, and Fargate is really, really expensive. Are a couple of the things we hear kind of qualitatively from customers and users at times. And I'd say that sometimes that's not wrong. You certainly can set up Fargate in a way that is going to be on the slow side. You can set up in ways that are going to cost you a lot of money. But I've also seen customers being very successful, having highly performant, mission critical, global scale applications running on Fargate in a very cost effective manner. And so we're going to kind of lean in on how do we get from A to B, and what are some things we should be thinking about when we're architecting these sorts of solutions. So to start off with, I also find it really helpful in that Fargate can sometimes feel like a black box at times. So I like to kind of dispel a little bit about what's happening under the hood, and kind of just make sure we're starting from a common ground of how Fargate's working from the moment that we kind of say we want a container to when we have a container up and running inside of Fargate. So this may be a review.
And just before you start that, maybe not everybody may be aware. Can you explain to me what Fargate is?
Oh, absolutely.
In a couple of words.
Yes, so AWS Fargate is really a special capability inside of AWS. It's how you are able to run what we call serverless containers in AWS's container portfolio. So we think of Fargate more as a feature or a capability. It's not a service that I walk in and say, "Hi AWS, I'd like 5 Fargates, please." But it's something that when we're using ECS or EKS, when we're using these orchestrators, we have the option of either deploying our data plane, our containers, either on EC2 nodes in a very traditional container environment, where we take n number of EC2 nodes, we cluster them together, we use an orchestrator on top, very traditional way. Or alternatively, we can utilize Fargate. And what Fargate does is, I used that word serverless before. We've been using that nomenclature of serverless container. What we mean by that is that if we're using ECS or EKS, we can opt to use Fargate. Fargate will shift some of the burden of management of everything beneath the container to AWS. So it gets you out of the world of deploying EC2 nodes, custom AMIs or AMIs that you have to harden, deploy every single month, go out and keep all those EC2 nodes fed and watered over extended periods of time. From a capacity perspective, if you need more Fargate, you simply scale out a service in ECS or EKS, and as long as you're within quota, more capacity is there. So it provides
Yeah.
a way an easier operating model when you're working with containers. And then I'll talk about some of the other kind of differences as we get here as well, because there's some nuances that are kind of important for today's topic as well. Does that make sense?
Okay, and just before we continue, we started, I just wanted to give a shout out to Robert Tables and I apologize if I'm butchering the name, it's Takatar Zina, who's going to be doing their cloud practitioner exam tomorrow. So lots of luck. I hope it gets fine.
Awesome.
And with that, let's dive into under the hood of Fargate.
Yeah, absolutely. So, the kind of the last value prop I'd also just kind of mention out there is security is something that is very near and dear to Fargate's heart. In that EC2 world, you're running multiple different containers all in the same EC2 node. You could have 1, 5, 10, 30, however many containers, all sharing a kernel. In a Fargate world, when you deploy one ECS task, one EKS pod, you're getting a one-to-one mapping with the infrastructure. So you have only your workload running on that infrastructure. You're not sharing a kernel with any other workloads or any other team's apps. There's a nice isolation model that's not only involving C groups and namespaces of the container, but also a hypervisor layer with the virtual machine. So we do that out of the box, and something you configure just how it's built, along with things like not allowing privileged containers, no host mounts. We come in a more kind of prescribed lockdown environment in Fargate that security teams generally really appreciate, because you don't have to do as much hardening as you would in an EC2 world.
And I assume, as the question which came in, it doesn't support nested virtualization, does it?
It does not today. Yeah, it's something you need to kind of run on EC2, and that's we're pretty quick to say, Fargate is not the option for 100% of every workload that's ever been created by mankind. There are times where we, as AWS, will actively say, actually, I think you're better off on EC2. That's times when you have very bespoke requirements around the performance of EC2 nodes, when you need to do things like nested virt, bare metal, those sorts of things are best in the EC2 realm. Fargate is where you typically are okay giving up some of the control you have in EC2 to gain some of the convenience of that serverless model, letting AWS handle a lot of the patching, hardening, and maintenance of that environment.
Yeah.
So good. So in the Fargate world, when I come in and say, "Hey, Fargate, I'd like to deploy 3 containers, please," what's happening under the hood is that's coming in through AWS. That can be a CLI, be the console, through an API, Terraform, CDK, whatever you choose. When you go and deploy, Fargate is going to take that request and it's going to find you some infrastructure. The way Fargate works is that it's not all smoke and mirrors with special hardware or anything like that. It's EC2. So Fargate is a user of EC2 that we build on top of this whole managed Fargate layer. But at the bottom, just like in most AWS services, it's EC2 at the end of the day. What Fargate does is that in every region, just about every region, every availability zone around the globe, we have a pool of servers that Fargate has running at all times. That's how the implementation works today. That's subject to change in the future, but we pre-warm these, so from a performance perspective, they're warm and they're ready to go. The composition of these pools looks a little bit different from region to region, AZ to AZ, but essentially it's EC2 nodes. These are made up of a mixture of different families and SKUs. But I'd say one of the nice parts about this is that since Fargate's a managed service, when we upgrade these pools, you get those benefits automatically. So over the past year, we've spent a lot of time really upgrading these pools, getting rid of all of our older Zen instances, going all in on things like Nitro. So by doing nothing over the past year, your Fargate got faster. We didn't raise prices, but your instances got faster. That's part of the benefit of running with a managed service there. But these pools scale out and in based on the demand in those regions. We spend a lot of time managing that capacity for you. So there's more than just 6 EC2 nodes. This is just a visualization. But essentially what happens is that Fargate will come in and say, hey, it'll pluck out 3 of those instances, and then it starts setting everything up for you. And so there's a lot of steps that happen in the background. This is a bit contrived, but Fargate's doing things on your behalf. So it's taking the ENI that's on that EC2 node, it attaches it to your VPC that you configured in your ECS task definition. So we're going to focus more on ECS Fargate today.
Okay.
It'll connect the Fargate agent to the ECS control plane so we can schedule and manage those containers. It'll pull a container image, start a task. If you have a load balancer, it'll connect that. It'll do health checks. There's all sorts of things happening as you're sitting there in the console looking at a Fargate task saying pending and kind of waiting it for it to come up and be ready. So when it comes to performance, kind of understanding what's happening is helpful here. Stuff happening. Exactly, Robert.
Very
Yeah.
much so.
I love it. Yeah, I need a strong, wizard's hat of some sort. Maybe some long sleeves, some my Gandalf fit is kind of lacking today. Good. So all these things are happening in the background, and I bring this up to say there's not a lot of knobs and buttons that we expose as a managed service to you that you can control. So like you can't go in and adjust the logic for the ENI attach. Just not something you can do. You can
or
choose
attach multiple ENIs or something like that as well.
exactly.
Fargate.
Yeah, if you've got all
Have
those,
less control.
that's exactly where kind of an EC2 is probably a better spot for you if you have really specific requirements or an ENIs, for example. But some things we can control are, do I use a load balancer or not? Adding a load balancer will add time to this provisioning kind of setup stage. And if you don't need a load balancer, leave it off. It'll be cheaper and faster not having that. We see a lot of folks kind of using a lot of LBs all over the place. It can be a little faster not having those. But the big main one I want to focus on today is this pulling of a container image. And so we talked a moment ago about how in the Fargate world, you have one task running on one set of infrastructure and that nice mapping. That's great for security. It's great for isolation. But what happens is that it's causing you to round trip to your registry to pull that image down every single time. For these 3 containers in my example, each one of those 3 is going to come up round trip to ECR. The second one's coming up round tripping to ECR. We parallelize it, but each one's having that round trip, which is different and a very nuanced difference than on EC2, where typically we make that round trip once to a registry and that image is cached locally on that node. So that if containers 2 and 3 landed on that same node, there's no round trip. Containers just start because you're effectively, after that round trip, caching that image locally. Fargate doesn't have that notion because you have such isolated, independent infrastructure from each other. That's a pretty big difference in what contributes to, hey, why does it take me, 45 seconds, 60 seconds, 90 seconds to get a Fargate task up and running? A lot of that time is spent with the container image. If you throw a 10 gigabyte container image in there, great, Fargate will run it, more power to you, let's go. But it is going to take time to go across the network, grab 10 gigs of an image and bring that back. This is one of the levers we have to pull here.
So let me ask you a question. If we were going to kind of slightly diving further in, so if, for example, I would take an EC2 instance to run a single task container and a Fargate task, and I would say deploy the same task, same size image to both of them. For the first time, there's nothing been running on either of them. Of course, on Fargate, it's on its own, and EC2 hasn't run anything before.
Right.
I would think there, of course, the fact of attaching an ENI to the VPC, we're without load balancers, it should be relatively more or less pretty much close enough to each other for the first time when the launch of the first task.
Yeah. If EC2 doesn't have the image pre-cache, it's just sitting there, it's going to have to round trip just like Fargate would. So the benefits would really just be the subsequent pulls after that initial.
Exactly. So if you if you deploy multiple instances of that container on EC2, it'll be a lot faster because you don't have to, as you say, run up the whole VM and pull the full container image again at 10 gigabytes coming back in, which will take that amount of time.
Exactly. The other piece there is, if we're needing to, in the container world, we're always scaling kind of at 2 layers. We've got the number of containers running and the number of nodes for infrastructure. If we need to scale the EC2 nodes out, then all of a sudden we're back to waiting for EC2 nodes to come back up, attached to the ECS control. But you get into some of those same issues there. So if the nodes are pre-provisioned, sitting there just waiting for a container, it's pretty fast. As soon as you need to auto scale an ASG, for example, that adds a lot of time in the EC2 world, where Fargate sometimes can be faster because those are pre-warmed and ready to go rather than a cold start like from EC2. So it just kind of depends.
And I assume you're going to tell us now, of course, that we kind of solve this because our customers have been asking and say it takes too long to run a big image putting from Fargate, and that's what we're going to do. So how did we do this?
Yeah, so that we've got a couple different ways, and so I'm going to start with a quick review, and you're going to say, Stephen, why this is really elementary? Why are we talking about this? I'll say because this comes up a lot with customers, and that's really we're going to start with kind of the basics, and we'll work into some of what AWS has done innovation-wise. But I always like to talk about image size, and so this is going to be a quick refresher, kind of Dockerfile best practices here. But if you're new to containers or just haven't looked at this stuff in a while, in the EC2 world, image size is kind of a nice to have. Yeah, we know we probably should be optimized. In a Fargate world, it matters a lot because every additional megabyte, every 10 megs, every 100 megs of extra space is round tripping every single time. And so if we can trim out 50 megs here, 100 megs there, it makes a big difference to our performance. So as a quick refresher, base images inside of Docker files matter a lot. So if you're coming in from an EC2 world, Ubuntu's been your standard, just as an example. Ubuntu, RHEL, you name your Linux flavor. If you come in and say from Ubuntu, that's going to start you with a base layer north of 100 megs just for that base image before you even put a single byte of your app in there. That's, Ubuntu is great as a host operating system. It's got all sorts of great SSH daemons, you got FTP, all these utilities. It's great for a host OS. You don't really need all that inside of a container, where we essentially just need
Right.
the things for your application rather than the OS. So utilizing minimal base images, things like Alpine, distroless, some of the folks that Wolfie and others are doing now for very secure base images, is a great place to start to really drive that down. So I'm partial to Alpine. There's a bunch out there. Alpine is around 10 megs, so maybe 1/10 of
Something
what
like that, yeah.
Ubuntu would be. Yeah, much smaller. Really starting with these smaller kind of more Debian flavors and things that are much smaller is a great place to start. So just in there, kind of obligatory. Let's start with a small base image. Additionally, Docker images have this great thing on multi-stage builds. What this means is if you have a compiled language, we're talking Java, .NET, Golang, as where JavaScript is at nowadays with things like Next.js, there's a lot of compilation going on in even front-end languages. You need things like SDKs and binaries to go do that compilation. Those SDKs are really critical at build time. You want to be able to compile binaries and files, but when it comes to running, you probably don't need all those extra SDKs. They're just extra cruft in your Docker files. So multi-stage builds allow us to kind of split those out and say, hey, in this first build, that's where we have all of our large SDK components that we need for compilation, run through all this, spit out some files or binaries. Then in this second stage, this run stage, that's where we can use kind of a slim base image like Alpine or others, grab just the files we need from that first stage, copy them into the second, and now we have a very slim base image or final image that gets output after the build just for running that application. So multi-stage builds really a best practice for keeping files really small, as small as possible for your images. And then finally, one last one comes out of an exact time with a customer who was saying, hey, Stephen, we've got Fargate's taken forever. We don't really know why. Our app's not that big. It's a simple little API. It's not doing it. It only has a couple routes. It's not that big, but it's taken us 2-3 minutes to spin up here. And I tell this story a lot, but what we found is that it was a mono repo in Git that they were utilizing. They had a /docs path here that had markdown files for documentation, but it had a bunch of high resolution screenshots and images. It had some pre-recorded videos that was doing documentation and training, all sitting in the same repo. In the Docker file, they had done just a copy wildcard, copy star, and all of that was being brought into the container context when they built. So it was an extra couple hundred megs of files that we didn't need to run the application, but were just inadvertently getting sucked into the Docker image based on doing the copy star kind of nomenclature. So just friendly advice of, fine to have a mono repo, not going to get into that philosophical battle here. But if you have things in your repo that aren't germane or specific to running an application, either with your copy commands, be really specific with certain paths, or if you're going to use copy star, use a Docker ignore file. This is something that is not always well known, but we can say all of these paths that I define, don't put them in my Docker image, just leave them on the host. Don't want them in the container whatsoever. Great way. We were able to carve out a bunch of space out of his Docker file, shaved off 15 to 30 seconds of start time for Fargate. So again, none of these are earth-shattering rocket science sorts of things, but things I'd just like to start as a refresher because we run into this stuff regularly. Docker's now been around for 5 to 10 years, but there's still a lot of folks coming into containers early. Always nice to just mention some of these best practices.
Yep.
All right, so now
while
to
you
kind
take a drink, let me let you
sure.
breathe a tiny bit. I'm going to
Sure,
pop
yeah.
up some questions that came up from the chat. So the first one came in from Inspector Diameter. Can I run my own Linux kernels on Firecracker? Or can I just package OCI root FS images? So I assume OCI is talking about Oracle Cloud. If that might be correct, if I understand the
I think
the
so. Usually,
abbreviation.
I think of OCI as the Open Container Initiative, which is when I say Docker
okay.
image, like OCI is the more proper way of saying a Docker
Okay.
image, more rationalized there.
Okay.
But as far as so like Firecracker is something that you can go and do on EC2 and have full control on, but that's not something that's really exposed. If this is saying, can I run my own Linux kernels on Fargates? In Fargate, whether it's Firecracker, or Nitro, or Zen, or any kind of underlying infrastructure, we don't expose a lot of that kernel level piece. That's AWS's responsibility. There's not a lot of knobs and buttons to do anything in the kernel, including things like Linux capabilities, privileged containers. All that stuff is really off the table in a Fargate world. So if you needed to kind of get down to have that customization, we really point you to kind of EC2 with Firecracker or otherwise if you're doing kind of Linux kernel level changes.
And that is the same kind of question. I'm not going to pop it up on screen because it was a nice blob. It'll probably cover up the whole, all of us, and think about the fact of running privileged containers. So yes, in Fargate, you are more limited because as it is a managed service, we don't provide provide those options. There's certain things which are limited. There's certain things we do expose, some of the things that we don't. But
we do expose capsys ptrace is kind of the one Linux capability that is part of Fargate today. And I know the team at AWS, we're actively looking at expanding the story in the future to make this more flexible. We understand the pain points of not having lots of different Linux capabilities for certain workloads. We're constantly looking at how we can improve and make that more flexible in the future there.
And whatever Ray Kruger says, I 100% agree. I have no idea who Ray, but thank you very much, Ray. I completely agree with you, Steve. He is definitely the expert here.
I don't know if you can tell the blushing on camera or not, but I appreciate the kind words, Ray. So good. So from a perspective, this little refresher, I felt compelled to mention it because this comes up all the time in conversations. Now let's get into some of the really fun stuff. And so Sochi, which is, we were talking about OCI a second ago. The OCI in Sochi is for Open Container Initiative. That S is for Seekable. Seekable OCI is this project that, if you've been around Fargate since last summer, you may have heard about. AWS has a full container runtime team now in our Fargate team that's really focused in on making improvements and contributions at the runtime layer. And so what we discovered is that when we in Fargate today, just like in everywhere else, when I go to essentially say Docker run or start a Fargate task, run task or otherwise, essentially we start at 0%. We pull down 100% of that file from a registry or of that image from a registry. We decompress that image and then we're ready to start the container. So that is where a lot of the time is taken in Fargate when we start up. What research was showing is that less than 10% of the files in a container image were actually needed for that initial startup. Certainly at some point in the life of the container, but we are the much bigger brains than I have figured out that, hey, we can actually kind of shift this on its head a little bit. And so what Sochi enables us to do is a feature that shipped in Fargate last summer. This is some open source work that we've been doing with Upstream Container D and other contributors in the community, was that we built a Container D we call Snapshotter. And so instead of utilizing an overlay file system like we always have with containers, loading everything and then starting, we flip that on its head. With Sochi, you actually start the container at step one. So we start that container up. As that container is needing files, as it's needing binary A, binary B, the snapshotter is interpreting through the fuse file system what files we need. It then goes to the registry and is plucking the different binaries that we need out of that registry, pulling just those files down and letting that application get started more quickly. So we're essentially lazy loading files into that container image rather than downloading 100% of that image. Then after, I think it's a 30-second timeout, so after 30 seconds, then we just pull the rest of the files down and make it all ready to go. But this is really kind of jump-starting your Fargate performance for those containers by lazy loading with Sochi. And you're saying, well, how does it know where to go find those files? It's all based on what we call a Sochi index. And so we essentially build an index in a container. You likely know a container image is made up of layers with lots of files inside of them. This index is going layer by layer, file by file, just building a large index of which file is at which spot in which layer in this big index file. When Fargate sees we've got an index, it goes, hey, it's Sochi time. And so it goes into Sochi mode, uses that fuse file system and does kind of this alternative way of loading. This is not something you have to think about or necessarily really do. All you need is a Sochi index file. So this can be done in a couple of ways. In GitHub, the Sochi Snapshotter project has a binary, a little CLI that you can run as part of your CI pipeline. If you want to build that index file, push it into ECR as a artifact that's going into the registry. More alternatively, and kind of a neat way, is that we've got the Sochi image builder, I think is the name, but there's essentially a project that says, hey, if you don't want to touch your CI pipeline, but you want to use Sochi, we've got a serverless way of building this index for you. And the way that works is You have your CI pipeline, you push into ECR. ECR is going to trigger an event bridge rule. So you can define some criteria. What images do I want to build with Sochi? For those rules, Event Bridge passes that over into Lambda. Lambda grabs that image, builds a Sochi index, pushes that into ECR. It's all done for you. You don't have to think about it. It's all done through Lambda and Event Bridge, which is super cool. So a couple different ways to get there, but we just really need that index file, and then Fargate will see it and go into Sochi mode. Um, the impact here, a couple things. I'll mention we got a case study that just went live this week that I took a screenshot of that I'll show in a moment from a customer who's been using this. That's saying they're seeing 60 to 70% reduction in the time it takes to start Fargate. So we're not nibbling around the edges with Sochi. This is 50, 60, 70% in decreases in time. It's much faster than not using Sochi. So you will see us be very full throated this year in really recommending Sochi, especially for large images. The one time where Sochi doesn't really make a lot of sense, if you've got a really small, 200 meg, 100 meg less kind of image, say you're going from scratch with Golang or something very tiny, Sochi is probably overkill and is not gonna be as quick. Where Sochi shines about 250 megs and above. So your uh, images that are a couple gigs, for example, really get a lot of benefit out of Sochi. Machine learning type images that have a bunch of frameworks and libraries in them, older Java or .NET applications that a lot of legacy code, very large application space, applications where you're packaging in sample data or other large artifacts that need to be done inside of that container where it balloons the size up. Sochi really is a great fit for all these different pieces. So I'll kind of pause there. Does that all make sense?
It does make sense. And I want to just add, I'm going to put a link here up on the screen and also in the notes of a Containers on the Couch where we did specifically diving into all of these things with Ollie of exactly, and also giving you the links also, as you said, for the serverless solution, which will allow you to automatically create those indexes, Sochi indexes, Sochi indexes for you. I'm sorry, it's 10:30 and I'm a little bit tired, but it's okay.
Of course.
So you can, of course, find it on the channel, on the Containers on the Couch on YouTube. Watch it. It was very interesting. Dives very, very deeply into how this actually works. And of course, give us the feedback if you want to hear anything more about it. We can probably get Ollie back probably we'll have actually Ollie on the show very soon.
Oh, perfect. I didn't. Yeah, if you've had all that in here, then you've got the master at work there. He's done some great work this fall. Reinvents, built a whole workshop there, a bunch of blogs this fall. So anything with Sochi, yeah, check out that video. Just some really exciting work. And I think what I love about this, it's an area where AWS really collaborated with the open source community, really built on the shoulders of giants that have come before us within the containerd community and otherwise. It's just some really cool tech. We're trying to make to me, it feels like a better mousetrap in some ways and a smarter way to go about this specific to Fargate. But we're getting into a world where you can take Sochi and run it on EC2 and other places with containerd, and so that you'll just see us continue to invest in Sochi going forward. So the last piece I want to call out around performance is another kind of area that before we had Sochi, our primary recommendation when it came to tuning Fargate workloads was with kind of a different approach here, and that's utilizing what we call Z standard compression. ZSTD is not the best shorthand, but Z standard compression is a compression algorithm that came out of the group at Meta, really sharp tech. Essentially what this allows us to do is to get a better compression ratio, so you can squish stuff down smaller, so it's smaller over the wire, which is very important for Fargate, and decompressing Z standard compressed images is much faster. Again, great for Fargate where every second matters, provides some benefits here. By default, since the dawn of time in the Docker world, when I said Docker build or I'm building a container image, that was utilizing gzip compression. It's kind of the default, which is great. No hate towards gzip. Gzip's great. We love gzip. But when it comes to tuning, we're able to pass in Z standard and switch that mode and get a more optimized image here. So if you're utilizing things like BuildX and some other build tools, many of them do support Z standard compression. It's been supported in containerd for a couple of years now. And this is an area that we've had a handful of customers that are very performance minded have been able to utilize Z standard. Fargate sees that and just simply runs it. It can support that media type. And works fine. So Z standard would be one way to, again, we typically see somewhere, around 20% decreases. So it's not quite as juicy as Sochi, but for smaller images or times where you really want to optimize things that don't work well with Sochi. Z standard is kind of the other way that we've been recommending the last couple of years. We've got a really great blog post from a year or two ago about utilizing Z standard compression. If you want to go find that, goes way down in the
I'll
weeds
see if I can find
of
it.
everything we need there. So just to preempt a question, can I use Z standard with Sochi? Not yet. Sochi is only about 6 months old. There is a GitHub issue open, so you can subscribe and follow there. It is something I know the team is kind of looking at for future enhancements for Sochi, is going to be able to support images baked with Z standard going into the Sochi system there as well.
And that you mentioned the blog post. Here we go.
Perfect. Yeah. So that's the way. So again, so across all three of these, all of these are all about, how can we be more efficient with our container images? How can we send less data across the wire so that pulls are done faster? How can we decompress more quickly? How can we start the container faster? That's times that can take, 30 or 45 seconds. And if we can squish that down to 10 or 15 seconds, we're getting a big savings on each individual task. That's nice for 2 tasks. It's great for 2,000 tasks. So it can be much more efficient there.
Before we go into, I think, the second
Yeah.
half of what we're going to be
Yeah.
talking about, I want to just, for everybody who has just joined and weren't here in the beginning, we're here with Stephen and myself on talking about optimizing your container workloads on AWS Fargate on ECS. We've been speaking up until now about the fact of how to optimize the performance of the images. And if you were watching this on the recording, that was the first half hour. And now we're going to go into the fact of how we're going to optimize. Customers can use this to optimize for their cost.
Perfect. Thank you for the excellent summary. And before we get, the last thing I would just kind of say on this kind of side when it comes to Sochi, this is a case study that went live like 3 days ago, earlier this week, from a fintech company called Flywire, does payment processing. They were in a private preview for Sochi last year. Now have come out with a very full-throated endorsement of Sochi. They've got a quote in there that I plucked out, but they were saying, their pipelines are running 60% faster than before. Great to see customers be able to get this tech and to see it making meaningful, big impact for their workloads. So again, take it for a spin. Let us know if that's something that we're in the early days of Sochi still. Open up GitHub issues, send feedback in. Would love to help innovate and make this even better moving forward. So check out that case study. Some great data points from a real customer, not just some AWS. A customer saying Sochi is good, not just some AWS guys saying that Sochi is good.
We know it's good, but that's okay.
Yeah.
We also like our customers who would agree with us sometimes.
Absolutely. Okay, so let's kind of shift over to costs. And so I don't know if I've talked to a customer in the last 18 months where cost has not come up, and for good reason.
I wonder why.
Yeah, I don't. Yeah, just with the world, cost has always been important, but it seems to be never more important than here recently. So, I'm going to talk about a couple of techniques and ways where we can really start driving down some of the cost of Fargate in a couple of different ways. The first place I'd love to start is Graviton. This is where I start with all of my conversations. My first response out of my mouth when I hear Fargate's expensive is, "Hey, are you using Graviton?" And that's informed by a particular customer about 2 years ago, soon after we released support for Graviton and Fargate. So if you'll enable me, I'll get a mosey on in a story. I'll bring it back. But here at AWS, one of our leadership principles is customer obsession. We love customers, and so from that, myself and several others, we track our big customers, our top 10, top 100 customers, week over week, month over month, year over year. The data is really important to see, hey, who's growing, how can we help accelerate them? Are there problems? And really identify who we can help with. So we had one of these customers, top 10 customer for Fargate, huge customer, great partner, great use cases. It's been at reInvent, been referenceable, great customer. So they had been really climbing with their growth, up and up and up. And then one week we come in and we just see the bar literally is like zooming down into the floor. And so at AWS, that's not great. And some of the little red sirens start going off internally. Lots of folks are saying, "Hey, this customer, are they okay? Are they upset? Are they leaving Fargate? Are they leaving AWS? What's wrong?" It was a bit of a fire drill internally, right? So it got some eyeballs on it. So we very quickly get a hold of the customer, get on a call. I say, "Hey, what's happening? Are you dissatisfied with Fargate? Is it something we did? What's happened?" And as we dug in with the customer, what they were saying was, they had a couple of developers who saw that this Graviton thing had shipped for Fargate. They were just kicking the tires on it, and so they found that, hey, it was pretty easy to convert the containers over into containers that work with Graviton. They went and deployed that in non-production. It looked good, so they spent in about 10 days moved their entire production stack from x86 over to Graviton. And once they got there, they realized that from all their dashboards, they were over provisioned. And so they started turning off containers, started turning off ECS tasks. And they ended up shaving down their environment by about 20%. And so the line we saw going down was a 20% decrease. What was happening there is the customer wasn't upset at Fargate. They were thrilled that they were able to turn off tasks that were running in Fargate. They were doing that because those Graviton workloads could serve the same amount of traffic for their customers with fewer tasks coming from Fargate. So that was something that kind of helped click for me. That hey, this is something more than just architecture and really slick keynote stuff at reInvent. This is something that's actually providing a lot of value to customers. It's something I talk about all the time. But at the end of the
And
yeah.
Graviton, of course, we said it works with ECS and EKS, so only ECS.
So with Fargate today, the Graviton support is specific to ECS Fargate. If you need it on EC2, that'll work across ECS or EKS. You can use that as well. And I should have said on the front end. So Graviton is really AWS's ARM64 architecture chips. So instead of x86 is kind of the traditional way, ARM-based chipsets that you may have a MacBook M1 chip that you're using today. Those are all ARM-based. Graviton is a project that AWS builds and maintains silicon for ARM64 chipsets here as well. So if you're interested in getting started and really how do I adopt Graviton, oftentimes is if you're starting with some existing code or existing kind of DevOps pipelines, it's typically just extending what you've already got. So you may already today be writing code, you commit some code, you have a CI pipeline, picks that up, builds a container image. If I run Docker build on an x86 machine, baked into that container image, that becomes an x86 Docker image or OCI image, excuse me. So when it comes to something with ARM64 with Graviton, we need to build that container on ARM64 hardware. So what this typically looks like is we keep the x86 as is. We may add another runner to go build with ARM64. At that point, we can either just push those separate images into ECR, but typically what you'll see is combining x86 and ARM64 into a multi-architecture image. This is essentially one tag, tag 123, some sort of commit SHA or something like that, that has both flavors of the app all in that tag. So that if I'm on a laptop with x86 and I say Docker pull from ECR, it'll pull down my x86. If Mesh is on a nice new MacBook, he gets better hardware than I do. If he's on one of those nice new shiny MacBook Pros and he says Docker pull, that's going to pull down the ARM64. The container runtime figures that out for you. It's great. But it takes a smidge of investment here. I'm not going to say there's a magical Graviton wand. We haven't gotten that sorted out yet. But the ROI here is that once you have these ARM64 based images, you can then configure Fargate via an ECS task definition, ECS service definition to utilize Graviton, which is going to be a little bit cheaper and a little bit more performant than running on x86, and is a way to really drive down a lot of that cost. So again, these are kind of standard OCI kind of image, very simplified workflow here, but it's all about once you get that image, then you're good to go. If we were having this conversation 2, 3, 4 years ago, ARM64 had a bunch of nuances. There were a lot of container ecosystem partners that you may run as sidecars or other code libraries or frameworks that didn't all. Sometimes they butted heads with ARM64. It was kind of round peg square hole at times. I'd say today in 2024 that is completely changed. It's rare that we're running across integrations or frameworks or apps that just don't work in ARM64. Things have gotten a lot better in the community, and that's happening across AWS, across the whole container ecosystem and world there. So Graviton, if you're just starting from scratch with Fargate, I go as far as say, hey, just start with Graviton. If you don't have an existing x86 world, Graviton is a great place to start. And again, it's all ARM60. Graviton is kind of an AWS brand, but you can take an ARM64 image and go run it on your laptops, other places. It's not a lock-in play for AWS. It's just what we call our ARM64. You still get that portability of containers. So good. So that's Graviton. The other piece that always comes up in cost savings is Spot. And I love Spot. I hate Spot. It's a love-hate relationship. Spot is wonderful, but Spot is often misunderstood. And so, what Spot is really a pricing option of how you buy compute from AWS. This started with EC2, and it's continued on into Fargate. We have support for Spot and ECS with Fargate today. How Spot works is we say, look, we've got a lot of kind of extra capacity in our data center. We'll give you that compute for a discount if you're trying to incentivize you to use that. But there's a caveat. If we need that back to give to an on-demand customer, we reserve the right to yoink that back with 2 minutes of heads up and then go give to that other customer there. And so what's good to know about that is that yes, it's a really cheap price point, but there's some availability trade-offs that you have inherent to Spot. And why I say that, and why I've been a little cheeky is we've seen some workloads, we've seen some customers that have said, "Hey, Spot's really cheap. I know, I'll just move all of my production environment over to Spot." And that is great until until there's not spot capacity in those pools. And so there's not an SLA, or there's not a guarantee that thou shalt always have spot capacity. There are times where we may not have a spot instance. In most in 9 times out of 10, likely we'll take an instance back, reschedule you onto another instance, you're good to go, it's no problem. But there's no guarantee for that. And so we may have several seconds, several minutes, maybe several hours of no spot capacity, and something to be aware of. Additionally, in talking with developers, there's a bit of unease at times because they're saying, "Hey, look, if you're just going to go terminate my task with 2 minutes heads up, we don't want that to be jarring to our application. Our app is very sensitive; it's doing a lot of stuff. We need to kind of control that process." And so, we put out a blog post a couple years ago that I think helped, but we kind of talk about what happens under the hood when Spot needs to take that back. So in very simple terms, we're simply sending in a sig term, a Linux signal, kernel signal into that app that's running in Fargate. I view it kind of like if you've ever been at a bar right before closing time, they kind of say last call. Sig term is the last call of the Linux world. Yeah, it's kind of that's what you order now, and because we're winding down here. And so AWS is going to say, hey, 2 minutes heads up. The timer starts now. Do whatever you need to do. And so what we can do in our code is we can say, hey, look, if we get a sig term, do A, B, C, D, whatever we need to do for that app. That could be terminating database connections. It could be putting some work in progress files that took a long time to compute. Maybe we put that into S3 or EFS or new EBS storage that's available now in Fargate as of a couple weeks ago. It may be adding a message back onto a queue, changing a database option somewhere. Whatever your app needs to do, you can add that in your code, and you've got complete control over how that graceful shutdown happens. So that's something that is a standard kind of Linux thing to do, but it's not always something that developers are used to doing in a containerized environment there.
And Mario's comment is
Yeah.
correct. Your software idempotent is required. In other words, you have to have the
Yes.
fact of be ready for the fact that your application will go away within 2 minutes. And if your application, the code is not designed that way, then Spot will not be the right solution for you.
Exactly. So yeah, where Spot is great, non-production environments or production environments where availability is not of top concern. Spot is great in a lot of environments. Where I get really antsy is when we've got production traffic, customer traffic running through Spot. Because you may inadvertently have some time where you have an outage just from Spot capacity not being there and available. The other thing I would say, I'll just preempt to say, hey, Spot is not really intended to be this situation where you say, oh, I'll run 100% on Spot, and then if Spot's not available, I'll just fall back 100% to on demand. That's not really a pattern that we recommend either. Though inside of ECS, we do provide a mechanism called ECS capacity providers that if you want to mix and match some on demand for kind of my steady state, I may want to use Spot for either bursting or sprinkling in Spot. Capacity providers can let you mix and match on demand and Spot in a really neat way that's available there as well. The last caveat I would just say is that in the Spot world, we've been talking about this 2 minutes thing left and right. I'd say in the ECS world, ECS has this notion of, when we send that sig term and the sig kill, there's an interval that's defined. And so we use the same interval for kind of auto scaling, kind of scaling in, if we're doing auto scaling, if we're doing task maintenance. There's other times where we need to kind of gracefully go in and out of these tasks. In the ECS world, that we call this the stop timeout setting. You may have seen that in an ECS task definition, service definition. Stop timeout by default is 30 seconds. So there's a bit of a mismatch with Spot being 2 minutes. If you need a full 2 minutes, just adjust stop timeout. You can bump it up to 2 minutes in Fargate. You've got the full time to be able to wind that app down gracefully there. So that's Graviton, that's Spot, and I'd say it's today it's one or the other. We don't currently have Spot is currently just focused on x86. That's something that the team is working on from a roadmap perspective, is bringing in ARM64 into the Spot experience. That's something that's kind of in the short term path that we will be excited to see for those that want to standardize an ARM64 across on demand and Spot. That's coming very soon, but today more of an x86 kind of thing. So something I would just kind of call out. A couple of other kind of quick things to talk about with costs that have really come up in the last year that I want to talk about. are a couple of things. So one is AWS Compute Optimizer. This was a service that I was not overly familiar with until they shipped support for Fargate last year. So what Compute Optimizer does, it's a service inside of AWS. It's been around for EC2 for forever, but it helps us with kind of a core problem of Fargate, especially if we're migrating into Fargate. So when I bring an ECS task into Fargate for the first time, I have to set, as an operator, or developer, or platform owner, whoever, I have to set a vCPU and memory setting. That can be hard to figure out. I'll just be blunt, especially if you're coming from a containerized environment where you had 10 containers running on that node. Sometimes getting per container metrics can be a pain. And as far as how that'll behave in Fargate, honestly, it's kind of traditionally it's been a bit of a guess. Hey, let's make an informed guess and then tweak after we move over to Fargate up or down based on how the app's doing. What Compute Optimizer does is it brings some data to the party. And what this means is that, if I come in with my app and I say, I think I need 4 vCPU and 30 gigabytes of memory, Fargate has these pre-configured combinations of vCPU and memory. I may come and say, I'm pretty sure I need 4 vCPU and 30 gigs of memory. Oftentimes, and this is where when I hear, Stephen, Fargate is expensive, 9 times out of 10, this is because utilization is very, very low on Fargate. We make it very easy for you to come in and say, I need 16 vCPUs in Fargate. It's very expensive, but hey, we say, hey, Mation needs 16. We're going to give them 16. So it's very easy to over provision in Fargate. And what's different here is because you have dedicated infrastructure, you don't have noisy neighbors you got to worry about. You don't have to kind of pad it with some extra space for a bunch of other containers. You have dedicated infra. Your task and only your task get access to that. So in this example, if I come in with 4 vCPU and I have utilization at 40%, that's actually pretty good. We see a lot in the 5, 10, 15% utilized kind of areas there. What Compute Optimizer can do is you can enroll an ECS cluster or an entire account into Compute Optimizer. Then Compute Optimizer is just going to put its listening ears on, and it's going to sit there for minimum 24 hours and just analyze how those tasks are doing from a utilization perspective. It's then going to generate some recommendations. And so Compute Optimizer may look at my workload here and say, hey, Steven, you provision 4 vCPU, but you're never going above 50%. We think you could go down, split that in half to 2 vCPU. Your utilization will still be, will spike. It'll go up to maybe about 80%, but there's still some headroom there. We would recommend you reconfiguring your ECS task with 2 vCPU and however much memory I need there. That's something that is generated for you automatically using machine learning models. It's super, super interesting. And it shifts this from a kind of a guessing game or just taking educated guesses into having very data backed up based on historical usage, what I need to configure for my task. And if I give it a full cluster, it'll do this across 100, 1,000 tasks and services, and let me know what I need there. Conversely, if I'm running really hot, so it may say, hey, look, Stephen, you're at 2 vCPU and you're about to blow the lid off of this and you're going to have out of memory errors coming up soon. It may say you need to actually scale upwards from 2 to 4. So it works both ways and really helps at scale when you've got hundreds, thousands of tasks running. Finding those needles in a haystack of what's not right-sized, Compute Optimizer is a great option and a great tool for teams that are really trying to identify where they're really losing money and over-provisioned in a Fargate world. So Compute Optimizer is great. You certainly can roll your own with Container Insights, with Grafana dashboards, however you want to do metrics. This just makes things a bit more guided. It's not going to change these settings for you, but it'll make it paint by numbers over which tasks need to be changed for which vCPU memory settings for those environments. So check out Compute Optimizer. It supports ECS Fargate today. I don't believe they've shipped support for ECS on EC2. I may be wrong here, but I know at least at launch, it was only an ECS Fargate investment so far. I'm not sure the plans are on ECS EC2, but for Fargate, you're good to go here. And then finally, the most kind of softball kind of piece here that I always like to mention because I don't see it used as often as I wish I'd see it used is tagging. And I think this is like the best kept secret of ECS and Fargate. And so in a container world, traditionally, when we had EC2 nodes with n number of containers all stuck in there, it was hard figuring out which container used which amount of resources if we want to do things like chargeback or showback or just simple cost allocation inside of an organization. With ECS, because Fargate has dedicated infrastructure, you get really clean separation on this team used these containers of these size, this other team used these other tasks of these size. And so you can really kind of hone in on who's spending what. So if I have in 6 tasks here is a very simple example. Tagging is how I can carve this up and figure out, service A has these tasks, service B has these, and then I can extrapolate the cost of that infrastructure and get a really clear signal on who's spending what within the organization. This is something that is baked into AWS. We don't have to, I'm a love Kubernetes, got my CKA, but in the kube space, this is something where entire companies have sprung up to try to help solve this problem because it's so challenging as in an EC2 virtual machine world to carve up that piece of the pie with the right size pieces of pie there. This is just out of the box in AWS. You can just flip it on, add tags, and you're good to go. In the ECS world, we have this ECS managed tag notion where if you turn this on in your task definition, we'll go ahead and add cluster name, service name if needed into there. You can define custom tags in your definitions, and in a service, we'll just automatically append those into every instance of that service that's running. And then it flows directly into the cost and usage reporting or Kerr dashboard there. You have to tell Kerr which tags you want to filter on. Once you set that up one time, then you can come in and do filtering and pivoting on this stuff. So I may say, for my finance department, here's what they spent in December of 2023. Here's what marketing spent last year, and we can show that back to the bosses. We can identify where we're seeing big spikes in spending. We can identify, hey, that was the finance team doing something. They doubled what they spent last month. We better go talk to finance, figure out what's going on. It
Yeah.
gives you a place to hunt and better guidance than what we've had historically, which is, hey, we've just got all these tasks and all this expense. We don't know where it's coming from. Tagging is something that is dead simple to use. Bake it into CDK, Terraform, Pulumi, whatever you're using, and you're all set there. So that kind of does it for kind of rounds out our optimization piece. There's a bunch of things we didn't quite get into because I know a couple weeks ago you had a great auto scaling session from Containers from the Couch. That's another both from performance and cost, something we always like to talk about. Go back a couple weeks ago and they do a full deep dive there, which is great. Some additional kind of resources I would just mention. We've got a FinHack workshop on Workshop Studio. Take a screenshot. It's a big kind of ugly URL. I apologize for the GUID. But on Workshop Studio, there's a couple of other kind of financial flavored workshops you can work through. The scalability piece on containers on AWS is great. Shout out Nate Peck for making just some phenomenal content up there. And then a cost optimization checklist was a partnership with a customer a couple years ago that runs through some of the things we talked about today on just some things to be aware of and be thinking about when it comes to Fargate. So apologize for covering a lot of content in a relatively short amount of time. Hope that's been useful. But again, this was how we were able to take an ECS and Fargate environments and some techniques of how we can really increase performance, decrease cost, and have just a very tuned environment when we're running, again, mission critical sorts of workloads on top of Fargate that are trusted all around the globe by customers of every shape and size.
Yep.
So good. So Mesh, any other questions or other things that I can speak to with the time we have remaining?
I don't know. There was a question about SCAD. Do you know what SCAD stands for?
SCAD. Oh, let me.
Stands for hold on a second. I'll find it.
It might be an EKS
split cost
thing.
allocation data.
Yeah. So split cost, I think, was more so when you've got ECS being used with EC2 and bringing some of that into it's very closely related. But when you've got like Fargate and ECS, EC2 kind of being commingled and used, split cost allocation allows you to kind of get better separation, especially between workloads that are kind of regular apps running on ECS versus if you're utilizing AWS Batch. Batch can utilize ECS and ECS Fargate under the hood. And so cost allocation can help you split out some of that that's coming in from Batch versus from ECS there. That's about the extent of my knowledge of split cost allocation, but it kind of comes in when you're mixing and matching several different compute flavors together.
I think that was pretty much that from the questions. Everybody loves Graviton, also running Lambda on Graviton.
Mm-hmm.
So the wonderful thing about it is, as you said, maybe 3-4 years ago was pretty difficult to try and compile things in a different architecture.
Yep.
Today, it's essentially either doing a multi-architecture build on your local laptop, which means you're running another virtual machine in the background running a different platform, or using, as you say, multiple runners. Once you've got this set up and working in a seamless way, it's dead stupid simple in order to make a multi-architectural image.
Yeah, we've got a lot of good blog posts across, name your CI runner of choice from Code Pipeline over to GitHub Actions to Jenkins pipelines. There's such a proliferation of tools. The general pattern is more or less the same across all of those. And to your point, yeah, on local devices now, with things like BuildX being able to emulate other architectures, it can take a little bit longer, but you can even generate ARM64 images off of an x86 host with some emulation
Exactly.
that's going on there through things like Docker Desktop, things like Finch, other kinds of dev tooling that'll enable some of this as well.
Yeah.
Exciting times. But yeah,
Very much so.
the Lambda side is a little bit easier. You can just check a box and get Graviton. Containers, we have to spend a little bit of time, but again, it's set it and forget it once you get over that initial hump. And once it's all automated, it's not something you're really thinking about day to day once you get all the hooks all set up and running.
Okay, I'm going to paste something here in the chat and also on the screen. Is actually this slide deck from your Chalk Talk, which if anybody wants, of course, not all the slides or things Stephen showed today, but at least a good part of the concepts are based upon which you shared with everybody, attendees at reInvent. And you can download and use that slide deck if you want to dive a little bit deeper. I want to thank all the people on the chat. You've been awesome today. Yscale, Zero, and Mehmet, and Mario, and Robert, and who else is here? The IFAM 5, and of course to say good luck to Takatar Zina, who has another exam tomorrow. So good luck, and I'm sure you're going to ace it. And thank you very much for participating today. It was awesome. Great interaction with everybody. Thank you very much, Stephen, for joining us. It's always a pleasure to have you. I learn something new every time I talk to you. And as everybody says, your stories are awesome. Not because they're stories, but just the way it brings home the point home of the fact of how our customers are probably experiencing everything else that everybody else is. And these are things that you talk about and learn every day, and it's good to share with everybody else. So thank you very much for joining us today.
Awesome. A pleasure to be with you. Thank you for the invitation, Mesh. Thank you for everyone for coming, and just appreciate your engagement and spending some time here today to talk about Fargate. Thank you so much.
And as Robert says, golf clap, standing ovation, very well done. Thank you very much. For those of you who have not already hit that subscribe button and to get just on the Continuous on the Couch YouTube channel, please do so that you're notified. We stream here every week, this time on Thursdays, 12 o'clock Pacific. Also on Twitch, so you can also subscribe to the Twitch channel as well. There's a multitude of different kinds of shows, so you can find something for whatever your kind of interest on databases, networking, cost management. There's a whole schedule which you can look in from Twitch on the AWS Twitch channel, which is available pretty much not 24/7, but a good at least 12 hours a day, that you can find something to watch if you're really, really bored or if you're just very interested in AWS. See you next week, same time. We're going to have an EKS session next week. So again, thank you, Stephen. It was a pleasure, a lot of fun, and we'll see everybody next week.
Have a great day.
Bye.